The work of Nobel Prize has transformed our understanding of the world. While approaching the Nobel Prize winners in chemistry, we not only learn their achievements, but also the spirit of honesty, tenacity, innovation, and forging ahead.
Hello everyone, welcome to today's class, the Nobel Prize winner in chemistry. 同学们大家好，欢迎走进今天的课堂，化学诺贝尔奖得主。今天我要给大家介绍的是第一届化学诺贝尔奖得主范特霍夫。Today I will introduce you the first Nobel Prize winner in chemistry. His name is Jacobus van Hoff.We all know that the Nobel Prize began in 1901. But do you know who is the first winner of the Nobel Prize in chemistry? Yeah, he is Jacobus van Hoff. He worked at Berlin University at the time he won the prize. His prize nomination was for the extraordinary services he had rendered by the discovery of the law of the chemical dynamics and osmotic pressure in solutions. Jacob van Hoff is considered one of the founders of physical chemistry. Although many people thought van Hoff was a German scientist, actually he was born in Netherlands. After he obtained his PhD, he was a professor in Amsterdam for many years. But in 1896, he moved to Berlin, where he was offered a position with more research and less teaching. He formulated the osmotic pressure law, but also very important in stereochemistry for molecular structure. At a fundamental level, chemistry deals with how molecules are composed with atoms and how atoms and molecules come intact and form new substances. During the 1870s and 1880s, Jacobus van Hoff made pioneering contributions with respect to both the structure of molecules and various subsequence of events. Now you may ask me, what is the osmosis? Osmosis is the phenomenon that two different concentrations of solution are separated by membrane. The membrane that allows the solvent molecule to pass through, which does not have allow the soluted molecule to pass. As we can see from the picture here, water molecules or other pure solvent molecules from a low concentration solution pass through the semi-permeable membrane into a high concentration solution until the concentration of the two sides are equal. Before receiving his doctorate, van Hoff had already published his first book for the contribution of organic chemistry. In 1874, he accounted for the phenomenon of optical activity by assuming that the chemical bond between carbon atoms and his labels weigh directly towards the corner of the regular tetrahedral, as we can see here. This three-dimensional structure perfectly accounted for the isomers found in nature, stereochemistry. He shares the credit with the idea with French chemist Joseph Nobel, who independently came up with the same idea. In 1884, van Hoff published his research on chemistry kinetics named Its Studies in Chemical Dynamics, in which he described a new method for determining the order of a reaction, used graphics, and applied the law of thermodynamics to chemical equilibrium. He used the principles of thermodynamics to provide a mathematical model for the rate of chemical reactions, based on the changes in the concentration of reactants with time. Van Hoff showed how the previous independently developed concept of dynamic equilibrium that chemical equilibrium results when the rate of forward and reverse reactions are equal. The laws of mass action, that the concentration of substances affects the rates of reaction, and the equilibrium constant, which is the ratio of the concentration of starting materials to products at equilibrium, together form a coherent model for understanding the nature of chemical reaction. Finally, he showed mathematically how temperature, pressure, and mass affect the rate of chemical reactions. So how the heat generated from a reaction could be calculated from the mathematical equation that governs the final equilibrium rate. This relationship between the heats of reaction and equilibrium allowed Van Hoff to define the modern concept of chemical affinity. On the basis of his innovative and successful treatment of chemical affinity, Van Hoff was awarded on the first Nobel Prize for Chemistry in 1901. So today's class, I have introduced you Jacobus Van Hoff, the founder of physical chemistry and the first prize winner in chemistry in history. Thanks for watching.
大家好，据说范特霍夫在牧场养了许多奶牛，每天早上的任务就是把牛奶送给居民喝。但谁都不会想到，这个每天早上驾车为大家送奶的人，竟是著名的化学家。因为在化学动力学和化学热力学研究上的贡献，范特霍夫获得了1901年的诺贝尔化学奖，成为史上第一位获得诺贝尔化学奖的科学家。这当然与他自幼热爱化学和在数学、物理学方面广博而深厚的知识素养分不开。然而，助于哲学修养，不断探索科学方法，使他具有非凡的创造想象能力。小时候对化学实验的深厚兴趣，后来变成了他取得各项成果的基础。他重视实验，但又不像当时绝大多数科学家那样局限于狭隘的经验。他善于巧妙地运用数学方法去整理实验结果，并注意用内笔的逻辑推理，从数学方程式推导出一些理论上的新结论。这是他创立物理化学新学科的重要方法。他总是站在哲学的高度去把握问题的精髓，胜人一筹。好了，本次课到此结束，谢谢大家，再见。